Hello and welcome to my dark space today, because this is what we're going to do today. We're going to work with some light, well, some fire. We're doing a fire experiment. I am Phil and I am in my space today, but this is an experiment that you can do with responsible adults. You have probably done this type of reaction, but in a different way or related to something else. We are going to be mixing baking soda and vinegar, which you normally might use for a volcano type experiment to get the bubbles to come up. But what we want to talk today is actually the chemical reaction that happens and introduce you to what happens when you mix two things together. Because you always get something that is produced at the end of it, and it might not necessarily be what you had at the very start. We are going to talk about fire extinguishers, and various fire extinguishers you might see around your school, different buildings, and you'll see on the side of them, some of them have foam, some of them have other things, and even some of them have CO2 written on it. And what CO2 means is carbon dioxide, so carbon and two oxygens. And carbon dioxide is after you breathe in oxygen, and your lungs do their thing, and their blood brings it round, and it comes back out. When you breathe out carbon dioxide. It is a safe, natural chemical gas that is around everywhere. But it is also very useful for putting out fires. So for fires, there is a fire triangle, and you need three things for it to be able to burn. You need heat, a fuel, and some oxygen for it able to be combust. And what we are going to do today is we are going to use, because I have fire here, and it is lighting me greatly, we are going to use this reaction of vinegar and bicarbonate of soda to be able to mix things together. They have a chemical name after it, so they mix together, but they produce carbon dioxide. And you might have seen this happen, like I said, in reactions when you do the volcano. So I'm going to take bicarbonate of soda, also known as baking soda, and when I add vinegar to it, which is an acid, when I mix this in here, you'll see that it fizzes. It raises up, rises up, raises up, rises up, and inside each of these bubbles is some carbon dioxide. And I've measured it perfectly that it should just stop at the top and not overspill. I mean, like, I've done this really a lot. Phew, I was about to lose my reputation as a measurement scientist there. But inside this, the bubbles are bursting, but the carbon dioxide is staying in the glass because it is heavier than air. It sits down the bottom, so it doesn't want to flow up all over the place. And when I have it like this, and I pour out the carbon dioxide inside here, you see it goes out, because the carbon dioxide is one of the things that you don't need for fire. For fire, you need oxygen, you need fuel, and you need heat. So if you pour the carbon dioxide, the air, which is made up of the gas, the carbon dioxide, is heavier than air, so it sits at the bottom and it pours out like a liquid. When you're in your school and you see a fire extinguisher that has CO2 on it, when you pull that and aim it at a fire, it's pushing away the oxygen. Or if you have a water one and that you fire it at a fire, it takes away the heat, or even washes away some of the fuel, or even pushes away some of the oxygen. Now, I want to show you this a little bit bigger, because we always want to try things a little bit bigger. So for this, I have a bigger jug filled with more of the same chemical, bicarbonate of soda, and I have a bigger amount of vinegar. So we're going to mix them together. Now, what do we think is going to happen when I mix these two together? We've already seen it happen. Exactly. So we should be seeing bubbles happening. So when I pour this in, we should see bubbles, and they should be carbon dioxide filled. And you're going to see that same fizz, that bubbly reaction. So inside each of these bubbles is carbon dioxide. And then I'm going to lift up this tray, which I have a load of candles in, and it is sloped towards me. So when I pour the carbon dioxide in here, not the liquid, the gas, it should travel down and extinguish the candles. Should. But this is an experiment. We don't know if it's going to happen, but let's give it a go. So, there we go. See this side, they're gone out. They're gone out this side. You can see the smoke from them. No liquid is coming out, but the gas is going out. All of them going out. Going out. I'm gonna pour them here. This one. Oh, I've only one left. One left. No, we'll use the old-fashioned way for this one. Perfect. Because even with blowing air, you're pushing away what is used, or you're cooling it down, or you're even pushing away oxygen for it to keep igniting. Simple things with carbon dioxide. Chemicals are everything, and understanding them and knowing how they work in the world, and even seeing it in practical, happening in real life, in your school, seeing how a carbon dioxide fire extinguisher works, means that you are understanding science technology. And when you go to design your next adventure and your next invention, you can figure out what you need to do to make it all happen and make your life safe. Perfect. And also you can make dramatic entrance and exits like this if I slip into the darkness. Check out www.rte.ie/learn. Lots of lesson plans. Am I in the dark? I don't know, so I'll just run off this way.